The eVTOL industry is soaring with ambition, but is it on the verge of collapse? With staggering billion-dollar price tags, endless regulatory red tape, and uncertain public demand, even key players like Vertical Aerospace are struggling to stay aloft. In this video, we'll explore the top 3 challenges holding back the eVTOL revolution: massive funding gaps, a maze of complex certification rules, and public skepticism about the future of urban air taxis. Wondering if these hurdles are temporary roadblocks or signs of a deeper problem? Stay tuned to find out if air mobility is destined to transform transportation or if it's already spiraling into a nosedive. Welcome to our channel. Let's begin by discussing the challenges of securing funding. One of the biggest hurdles for eVTOL manufacturers, even for industry leaders like Vertical Aerospace, is obtaining sufficient capital. The costs associated with developing and certifying a new aircraft are staggering. Early eVTOL startups have already attracted over $100 million in initial investments. However, the journey to full-scale production and certification could push expenses well beyond $1 billion per aircraft. For comparison, Boom Supersonic's Overture airliner, which relies on established supersonic technology, anticipates development costs around $6 billion. Given that eVTOL technology is still largely uncharted, financial requirements are even more unpredictable. Traditional aerospace companies such as Airbus, Bell, and Boeing enjoy extensive funding pipelines for research and development. However, these firms are also very cautious. Corporate leaders may choose to terminate high-risk projects if market conditions shift or if progress is slower than anticipated. This cautious approach forces startups like Vertical Aerospace to seek alternative funding through venture capital and strategic partnerships. Many companies, including Beta Technologies, have broadened their revenue potential by collaborating with non-air taxi customers. For instance, Beta's partnership with United Therapeutics focuses on transporting human organs for transplantation, showcasing a wider application strategy. Another significant challenge is the nature of eVTOL pre-orders. Many announcements of large volume orders are based on non-binding letters of intent or memoranda of understanding, often lacking any upfront financial commitment. Unlike traditional aviation, where substantial deposits secure orders, most eVTOL agreements are speculative. This limited financial backing makes industry growth projections fragile. Testing market feasibility on routes like Manhattan to JFK Airport highlights the logistical and operational challenges involved. A Bell 505 helicopter, flying at a maximum cruise speed of 125 knots, can complete this journey in roughly 9 minutes. While eVTOLs aim to match or exceed this performance, they still face technical constraints regarding speed and payload capacity. Now let's discuss the regulatory hurdles. Meeting regulatory requirements is a complex and time-consuming process for any aviation innovation. The Federal Aviation Administration, FAA, plays a crucial role in establishing safety, redundancy, crashworthiness, and operational standards for commercial eVTOL aircraft. The certification of eVTOLs presents unique challenges due to their reliance on electric propulsion, vertical takeoff and landing capabilities, and autonomous systems, none of which have been fully proven in mainstream passenger transport. Autonomous flight is particularly vital for scaling operations, yet the technology is still several years away from readiness. Sikorsky's SARA, Sikorsky Autonomy Research Aircraft, built on a modified S-76 helicopter, represents a promising advancement towards self-flying aircraft. However, full autonomy in commercial passenger eVTOLs has yet to be demonstrated. Many companies are targeting commercial service by 2025, but without fully certified autonomous systems, human pilots will still be necessary. This need is further complicated by a pilot shortage. Between 1987 and 2017, the number of licensed U.S. pilots decreased by 30%, totaling 609,000, according to the FAA. Recruiting pilots for eVTOL fleets would substantially increase labor costs and slow down adoption. Regulations concerning autonomous systems add further layers of complexity. Invention's Verante Autopilot 4X, a redundant control system designed for critical eVTOL operations, adheres to aviation standards DO 178C, DO 254, and DO 160. This technology incorporates fail-safes to prevent single-point failures, highlighting the stringent requirements for redundancy and robustness. Certification timelines for such systems can extend for years, significantly affecting go-to-market strategies for companies like Vertical Aerospace. Airspace management introduces yet another challenge. While the skies are expansive, they require precise coordination for safe and efficient eVTOL operations. NASA's ongoing research into unmanned aircraft systems traffic management, UTM, underscores the necessity for scalable solutions that can automatically route aircraft, prevent collisions, and adapt to dynamic conditions. Unlike traditional aviation corridors, urban air mobility demands granular, real-time traffic oversight. Next, let's discuss market adoption uncertainty. Even if regulatory and funding challenges are addressed, market adoption remains a significant variable. Public acceptance of eVTOL services hinges on trust in safety, noise levels, cost-effectiveness, and overall convenience. For urban air taxis to succeed, they must not only compete with ground transportation in speed, but also in affordability and accessibility. Safety concerns are likely to shape public perception. High-profile crashes during early trials could undermine trust and hinder adoption. The lessons learned from the Boeing 737 MAX incidents illustrate how automation failures can shake public confidence. Unlike traditional aircraft, eVTOLs will operate closer to buildings and people, increasing both risk and scrutiny. Therefore, companies must not only meet regulatory standards, but also actively educate the public about safety measures and emergency protocols. Noise pollution presents another challenge. While multi-rotor eVTOL aircraft are equipped with quieter electric motors, they still produce distinctive sound patterns that may disturb urban residents. Public resistance to noisy operations over residential areas could delay deployment. To gain community support and regulatory approval, Vertical Aerospace and its competitors must invest in noise reduction technology. Infrastructure readiness is also a crucial barrier to scaling operations. Successful eVTOL networks require vertiports, specialized hubs for takeoff, landing, and recharging. These facilities need to integrate seamlessly into urban environments, providing easy access through elevators, passenger lounges, and baggage systems. Unlike traditional airports, vertiports must accommodate a high frequency of short-haul trips with rapid turnaround times. Additionally, charging technology must offer fast, reliable power to keep fleets operational without delays. Moreover, the demand assumptions underpinning many business models invite scrutiny. Proposed air taxi routes, such as those between Manhattan and major airports, aim to provide faster alternatives to congested ground transport. However, time savings can diminish when considering boarding, security, and access to vertiports. If eVTOLs fail to deliver significant convenience advantages, adoption rates may remain low. Furthermore, companies relying solely on passenger services risk financial instability if early adoption falters. Diversifying into cargo logistics, emergency services, and industrial applications could create more stable revenue streams. What do you think? Can companies like Vertical Aerospace overcome these challenges and make flying taxis a reality? Or will the hurdles be too much to handle? Share your thoughts in the comments below.